Namaste my dear students, నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్. డైరెక్టర్ జేసీ సార్ ఆధ్వర్యంలో శశికాంత్ వాల్మీకి సార్ పర్యవేక్షణ నిర్వహిస్తున్న సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఈసెట్ 2023 రాసిన విద్యార్థులందరికీ మీరు అబ్జెక్షన్స్ పెట్టుకోనికి వీలుగా ఉండాలి అనే ఉద్దేశంతో ఈసెట్ పేపర్స్ అన్నిటిని బిట్ టు బిట్ ఎక్స్ప్లెయిన్ చేయడానికి ఈ వీడియో లెక్చర్ సిరీస్ మీ ముందుకు తీసుకురావడం జరిగింది. కాబట్టి మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో, ఎవరైతే క్వశ్చన్స్కి ఆన్సర్స్ తెలుసుకోవాలనుకుంటున్నారో, పూర్తి డీటెయిల్ ఎక్స్ప్లెనేషన్ ఈ వీడియో లెక్చర్స్ని ఖచ్చితంగా వాచ్ చేయండి. అలాగే మీ ఫ్రెండ్స్ అందరికీ కూడా ఈ వీడియో లెక్చర్ సిరీస్ని షేర్ చేయండి. దీంతో పాటుగా మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో వీళ్ళందరికీ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక ద్రోణాచార్య బ్యాచ్ ని ఇంట్రడ్యూస్ చేసింది. గత 25 సంవత్సరాలుగా ఎంతో మంది ఇంజనీర్లు తయారు చేసిన సంస్థ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ డిప్లొమా విద్యార్థులకి అండగా బాసటగా నిలవన ఉద్దేశంతో ఈ బ్యాచ్ ని మీ ముందుకు తీసుకురావడం జరిగింది. ఈ బ్యాచ్ లో భాగంగా మీ అందరికీ మొదటిగా మీరు బీటెక్ లోకి వెళ్ళిన వెంటనే ఇబ్బంది పడుతారు అనే ఉద్దేశంతో, ఆ ఇబ్బందిని పోగొడితేనే ఫ్రీ మైండ్ తో ఉంటేనే పని బాగా చేస్తారనే ఉద్దేశంతో బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్స్ ని ప్రొవైడ్ చేస్తున్నాం. బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్సే కాకుండా సిఆర్టీ క్యాంపస్ రిక్రూట్మెంట్ ట్రైనింగ్, దీనిలో భాగంగా ఆప్టిట్యూడ్, రీజనింగ్, ఇంగ్లీష్, అదేవిధంగా సిఆర్టీకి కావాల్సిన బేసిక్ కోడింగ్ లాంగ్వేజెస్ సి కావచ్చు, C++ కావచ్చు, జావా కావచ్చు, పైథాన్ కావచ్చు, వీటన్నిటిని మనము లైవ్ క్లాసెస్ ద్వారా అందిస్తాం. దీంతో పాటుగా థర్డ్ వన్ డిప్లొమా బేస్డ్ జాబ్స్ టెస్ట్ సిరీస్, మీరందరూ సంవత్సరం నుంచి కావచ్చు, సెకండ్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఫస్ట్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఈ సెట్ కొరకు ఇంజనీరింగ్ సబ్జెక్ట్స్ బాగా ప్రిపేర్ అయ్యారు. ఇదే ఇంజనీరింగ్ సబ్జెక్ట్స్ అనేది మీకు రేపు డిప్లొమా బేస్డ్ జాబ్స్ కూడా ఉండడం జరుగుతుంది. కాకపోతే మీరు రేపు జాబ్ పడినప్పుడు రెడీగా ఉండాలంటే కన్సిస్టెంట్గా ప్రిపరేషన్ అది అవసరం అవడం జరుగుతుంది. కన్సిస్టెంట్గా మీరు ఆల్రెడీ మీ అందరూ బాగా ప్రిపేర్ అయ్యారు, మీకు సపోర్ట్ ఉండాలనే ఉద్దేశంతో ఒక టెస్ట్ సిరీస్ కూడా మనం ద్రోణాచార్య బ్యాచ్లో ఇంక్లూడ్ చేయడం జరిగింది. ఈ టెస్ట్ సిరీస్లో భాగంగా ప్రతి వీక్ టాపిక్ వైజ్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేస్తాం. టాపిక్ వైజ్ అయిపోయిన తర్వాత మనం మిక్స్డ్ టాపిక్స్ ఆర్ మిక్స్డ్ సబ్జెక్ట్స్ గ్రాండ్ టెస్ట్ కండక్ట్ చేస్తాం. ఫైనల్ గా ఓవరాల్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేయడం జరుగుతుంది. 1 ఇయర్ పాటుగా మీకు ఈ డిప్లొమా బేస్డ్ జాబ్స్ యొక్క టెస్ట్ సిరీస్ కోర్స్ అందించడం జరుగుతుంది. దీంతో పాటుగా 2 ఇయర్స్ వ్యాలిడిటీతో ఆల్ ఓవర్ ఇండియాలో ఎవరు తయారు చేయలేని విధంగా మన సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక గేట్ కోర్స్ని రెడీ చేయడం జరిగింది. ఆ గేట్ కోర్స్ విత్ వ్యాలిడిటీ ఆఫ్ 2 ఇయర్స్ అందించడం జరుగుతుంది. ఈ 4 మాడ్యూల్స్ మనము ద్రోణాచార్య బ్యాచ్లో అందించడం జరుగుతుంది. దీని విలువ సుమారుగా ₹1,00,000. కానీ ఈ కోర్సు మొత్తాన్ని ఫ్రీ ఆఫ్ కాస్ట్గా అందించడం జరుగుతుంది. జస్ట్ ఈ 2 సంవత్సరాల మెయింటెనెన్స్కి, అదేవిధంగా టెస్ట్ సిరీస్ కోసమని రిజిస్ట్రేషన్ ఫీజ్ ₹3,000 అనేది తీసుకోవడం జరుగుతుంది. ఎవరైతే డిప్లొమా కంప్లీట్ చేసుకుని బీటెక్ వెళ్తున్నారో వీళ్ళందరికీ ఒక మంచి అవకాశం ఇది. కాబట్టి ఈ అవకాశాన్ని మీరందరూ ఉపయోగించుకుంటారని ఆశిస్తున్నా. మీరు ఈ అవకాశాన్ని వినియోగించుకోవాలంటే ముందుగా మీరు మన అప్లికేషన్ స్పేస్ గేట్ అనే అప్లికేషన్ని డౌన్లోడ్ చేయండి. డౌన్లోడ్ చేసిన తర్వాత అందులో ప్రొఫైల్ సెక్షన్ ఉంటుంది. ఆ ప్రొఫైల్ సెక్షన్ మొత్తాన్ని ఫిల్ చేయండి. ఫిల్ చేసిన తర్వాత మీ అడ్మిషన్ ప్రాసెస్ కోసమని 9848692598 ఈ నెంబర్కి కాంటాక్ట్ అవ్వండి. అడ్మిషన్ ప్రాసెస్ ఎట్లా, అదేవిధంగా ఇంకేమైనా కోర్స్ డీటెయిల్స్ ఏమైనా కావాలంటే కూడా పూర్తి ఇన్ఫర్మేషన్ అందించడం జరుగుతుంది. మై డియర్ స్టూడెంట్స్, మీరందరూ ఈ అవకాశాన్ని వినియోగించుకుంటారని ఆశిస్తూ నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్.
Let us solve question number 138. The question is, a 3-phase induction motor runs at a speed of 1485 rpm at no load and 1350 rpm at full load when supplied from 50 Hz 3-phase line. So what is the speed at no load of the rotor field with respect to the rotor conductors? Option 1 the 15 rpm, option 2 150 rpm, option 3 25 rpm and option 4 the 250 rpm. So the speed of the induction motor at no load is given by the 1485 rpm or 50 Hz frequency. Speed of the induction motor at full load is at 1350 rpm. So under no load condition, induction motor rotates at a speed which is very nearer to the synchronous speed. So that synchronous speed of this motor is equal to 1500 rpm. So next one, the speed under no load condition, speed of the rotor under no load is a 1385 or 1485 rpm. So we require the speed of the rotor field, okay, at no load with respect to the rotor conductors here. So speed of the rotor field with respect to the rotor conductors, okay, the conductors, that is equal to ns minus the nr under no load condition. The ns is equal to 1500 rpm and nr is equal to 1485 rpm. So this is equal to 15 the rpm. So answer for this question, the 15 rpms. Option 1 is correct for this question. Got it? Question number 139. So assume that stator impedance of the induction motor is negligible. The frequency of the voltage applied to the motor is increased, keeping V by F ratio constant. The maximum motor torque. So these are options for this question. So now maximum torque, okay, is directly proportional. This one is a maximum torque is equal to the 180 by, okay, 2 pi ns, okay, E2 square by the 2x2 values. Now this T maximum you can write, so 180 by 2 pi ns is ns is equal to 120 f by the p. So now E is some constant, is directly proportional to some constant V1 square, and 2 is equal to 2 pi the fl, okay here. Suppose if you remove the all constant, maximum torque is directly proportional to the V1 by F whole square. When V by F ratio constant, then what will happen? The maximum torque produced by the motor is also constant. So mention that V by F ratio constant, so remains constant. But what about the slip corresponding to the maximum torque? The slip corresponding to the maximum torque is S maximum, that is equal to R2 by X2. So now this is equal to R2 divided by 2 phi FL. So S maximum, okay, is the inversely proportional to the frequency. The frequency here, the motor, the increase, the frequency of the voltage is increased, keeping V by F ratio constant. When frequency increases, the slip corresponding to the maximum torque decreases. Maximum torque remains constant, but the slip corresponding to the motor will decrease, okay, the smaller values of the slip. So now option 3 is the correct for this question. Got it? And next one, question number 140. The question is, a 3-phase induction motor is operating at a slip S. If it is supply leads are interchanged, then it's the slip that instant will be. So when supply leads are interchanged, the rotation of the rotor will be reversed. When rotation is a rotor is a reverse, slip is equal to ns minus n by, okay, ns value. So now this is equal to ns, okay, this is the slip corresponding to the backward field. So now this is equal to the ns plus n the divided by the ns value. So this equation can be written as the ns, okay, plus n the by, okay, ns. So here let us add plus ns minus ns value. So by solving this, okay, 2n divided by the ns minus of the ns minus n by ns value. So it is equal to 2 minus, okay, s, where s is the slip the corresponding to forward rotating magnetic field, and 2 minus s is the right answer for this question. Option 3 is the correct. Got it? And next one, question number 141. So for a constant load, the voltage, applied the voltage of the squirrel cage induction motor is reduced by factor of the 1 by root 2. Its current modified by a factor of option 1 is a 2, option 2 is a 1 by root 2, option 3 is a 1 by 2, and option 4 is the root 2 values. So let assume the let V11 is equal to the V, the S1 is equal to oka S, and in this case V12 applied voltage is equal to V by root 2. So now in this case the here what will happen is the slip of the motor. First let us find out the slip of the motor. The slip is so in the torque constant condition, torque is always directly proportional to the V1 square, the S into V1 square valves. Okay, torque is directly proportional to S. So at torque constant condition, so this equation you can write S1 into V1 square, the into S2 the V12 square. Now we required slip S2 is equal to the S11 V11 square divided by okay, V12 square. So it is the S, and next one V11 is the V square. So now it is a V12 is equal to, so 1 by the V by root 2, okay, now whole square. Now it is equal to 2 times of the S1. So now slip will become double. Okay, that slip. When slip is a double, what about the stator current? The stator current, okay, that is directly proportional to S into the okay, S into the V1. So now here current I12 is equal to, okay, this stator current I1, the I12 is equal to the here I12 by I11, that is equal to here. So this stator current I12 equal to I11 by S2 by S1, the into V12 by the V11. So just substitute here I12 is by I11, the is equal to S2 is a 2 times of S, and V12 is a V by root 2 and divided by V. So VV is a cancelled out. I12 is equal to root 2 times of the I11. So now stator current is modified by a factor of the root 2. So option the 4 is correct for this question. Got it? So next one, question number 142. A 8-pole single phase induction motor is running at 690 rpm. The slip respect to the forward and backward fields respectively. So now we need to find out the slip corresponding to the backward and back. So consider here poles are frequency is not mentioned. In general, F is equal to supply frequency 50 Hertz, and the number of poles Fp is equal to 8 number of the poles. So this we need to consider this part. So consider F is equal to the 50 Hertz. And what about the synchronous speed? Ns is equal to 120 F by the P. So 120 into 50 Hertz divided by 50, the divided by 8 number of the poles. Okay, now this is equal to 750 rpm. Okay, 750 rpm valve. So Ns we got, and we can find out slip corresponding to the forward field. So Ns minus N by the Ns value. So Ns minus N by Ns. Okay, this is equal to this one is Ns is the 750 minus, okay, N is equal to the 690, the divided by the 750. So it is equal to 0.08. Now slip corresponding to the backward field is equal to 2 minus SF. Now it is a 2 minus 0.08. So it is equal to 1.92. So answer for this question, option 1 is the correct. And next question number 143. In the equivalent circuit of double cage induction motor, the rotor cases can be considered. So two rotors are considered to be connected in parallel. So option 1 is correct for this question. Option 1 is the right.
Question number 145. What is the output for the circuit given in figure? Assume the diodes are ideal diodes. See here, there are two diodes are given. This is diode D1 and this is diode D2. And this is N terminal of PN junction diode. This is P terminal of PN junction diode. This is also N terminal and this is P terminal. We know that ideal diode means what? A diode is said to be an ideal diode when it is in forward bias. When the diode is in forward bias, then it acts as a short circuit, and when the diode is in reverse bias, it acts as open circuit. So this is the logic here. So when it is open circuit, the voltage is maximum, and when it is short circuit, the voltage is 0. From that concept, what is the output voltage here means answer is minus 5 volts. What is the answer here? Minus 5 volts. Otherwise, one more method is also there, that is equals to OR gate using diodes. Then also what is the output here? Minus 5 volts. Next question. The primary function of a filter in a rectifier: A. Minimize AC input variation. B. Suppress odd harmonics in the rectifier output. Stabilize DC level of the output voltage. Removes ripples from the rectified output. Here filter means what? It is a circuit which is used to remove unwanted signal, at the same time allows wanted signal. Generally, rectifiers are used to convert AC input voltage into DC output. So here the basic function of filter in a rectifier is to remove ripples from the rectified output. See here, already we know that in half wave rectifier, this is the output waveform in half wave rectifier. Similarly, in full wave rectifier is also, this is the output waveform. This is the output waveform. But this is not pure DC. It is a combination of AC and DC. So to remove AC component from these outputs, these two outputs in half wave rectifier as well as full wave rectifier, we are using filters. Already we know that filter circuit consists inductors and capacitors. Hence here the basic function of filter is what? To remove ripples from the rectified output. That's why in regulated power supply also, the rectifier output is connected to filters. The rectifier output is connected to filter. See here, in options also you mentioned that what? It removes ripples from the rectified output, means the rectifier output is given to filter. What is the function of filter? Filter is a circuit is used to remove unwanted signal, at the same time allows wanted signal. Here unwanted is AC and wanted is DC. So here option 4 is correct answer. Option 4 is the correct answer. And next question, question number 147. If one of the diode in a full wave bridge rectifier opens, then the output is 1/4 of the amplitude of the input voltage, half wave rectified voltage, and a 120 Hz voltage. So we know that in half wave rectifier we are using only one diode. In center tapped full wave rectifier we are using 2 diodes, and bridge rectifier we are using 4 diodes. Just first you remember that point. Half wave rectifier we are using 1 diode, whereas center tap full wave rectifier we are using 2 diodes, and bridge rectifier we are using 4 diodes. And here you remember one more point. In half wave rectifier, this is the output waveform, and in center tap full wave rectifier and bridge rectifier, this is the output waveform. See here half wave rectifier we are obtaining only half of the wave at output side, but using center tap full wave rectifier and bridge rectifier we obtain a full wave. And one more important point, if it is center tap full wave rectifier, this output first half wave component is due to D1 only, and second half wave component is due to D2 only. Similarly, this is D1 and this is D2 if it is center tap full wave rectifier. And if it is bridge rectifier, see here there are 4 diodes. The 4 diodes are arranged in the form of bridge. Like this. The 4 diodes are arranged in the form of bridge like this. So this is D1 this is D2, this is D3 and this is D4. So here when input voltage positive D1 D3 forward, D2 D4 reverse, when input voltage negative D2 D4 forward, D1 D3 reverse. All this operation we discussed. So here I am explaining this output voltage. If it is bridge rectifier, see here, the first half wave component due to diodes D1 D3, and similarly this is due to D2 and D4. Like that I am writing here also what? D1 D3, here what? D2 D4. So now the question is, in a full wave rectifier, if any one of the diode, either D1, D2, D3, D4, any one of the diode open, then if it is D1 is open, this waveform is not existing. If it is D2 or D4 are open, this wave is not existing. Hence, if any one of the diode is open, then this full wave rectifier output waveform is similar to half wave rectifier output waveform. This is the answer. Option 3 is the correct answer, because here there is no output because one diode is open one diode. Here one diode is short. Here also same D1 D2, D1 is on, D2 off, D2 on, D1 off, like that. Here two diodes. So out of these 4 diodes, if any one of the diode is open, then the full wave rectifier output waveform is similar to half wave rectifier output. So option 3 is correct. Next question. In voltage amplifier, the load resistance should be. So here you remember one point. Based on output, amplifiers are classified into two types. Based on output, amplifiers are classified into two types. One is voltage amplifiers, and second one is power amplifiers. One is voltage amplifier and second one is what? Power amplifier. So here the main difference between voltage amplifier and power amplifier is what? Means with respect to I am explaining load resistance, output resistance I am explaining. So in voltage amplifier the load resistance as large as possible, but whereas in power amplifier the output resistance is very small. That's why these power amplifiers are mainly used for impedance matching purpose. Power amplifiers are mainly used for impedance matching, and voltage amplifier generally we are used to in public address, that means speakers like that. But here in voltage amplifier you remember the load resistance should be as large as possible. That's why when we are analyzing using H parameters also we are considering output resistance is infinity. So here for a good voltage amplifier the load resistance should be as large as possible. So option 1 is correct. Next question. Generally the gain of a transistor amplifier falls at high frequency due to, this is frequency amplifier response, frequency versus voltage gain AV. So any amplifier, whether it is feedback, without feedback, single stage, multi-stage, any amplifier frequency response is like this. Any amplifier frequency response. This is maximum voltage gain. This is AVM by root 2. So this is cutoff frequency FL, lower cutoff frequency. This is higher cutoff frequency FH. So an amplifier operation can be explained by using frequency response. Here the frequency response operation can be explained by using 3 regions: low frequency region, and this is mid frequency region, and this is high frequency region. Low frequency region, mid frequency region and high frequency region. Here in high frequency region in high frequency region, the question is what? In high frequency region, the gain of a transistor amplifier falls. That means decreases here. So in high frequency region, the gain of an amplifier decreases due to, is asking, that is answer, due to inter-electrode capacitors. Due to what? Inter-electrode capacitors. What are the two capacitors here? This is base, this is emitter, this is collector. So this is base and emitter, CBE, diffusion capacitance between base and emitter junction when emitter base junction is in forward bias. Similarly, this is CBC, transition capacitance of transistor when collector base junction is in reverse bias. So in high frequency region, the gain of an amplifier decreases due to inter-electrode capacitors. Inter-electrode capacitors. Inter-electrode capacitors. Or sometimes it is also known as internal capacitors or stray capacitors. Here is mentioned what? Internal capacitance of the device. Coupling capacitor, that is external capacitor, skin effect is not correct. Coupling capacitor at the output, that means this is mentioning this is a BC, sorry, this is CC, coupling capacitor, this is CB. So this is wrong, this is wrong, this is not here we are using. Only the correct answer is what? Internal capacitance of the device. In high frequency region, gain decreases due to internal capacitor. In low frequency region, also gain decreases here, that is due to this external capacitors. These two external capacitors are known as coupling capacitors, or input side is known as blocking capacitor, output side is known as coupling capacitor. Yes. Next question. This is digital electronics question. Minimize the following Boolean function f of a comma b comma c equal to sum of minterms 0, 1, 6, 7 and don't care 3, 5. So here, see here, this is, I am considering A, K map, this is BC, I am writing here 0, this is 1. And here I am writing, this is what? 0, 0, this is 0, 1, and what is this? 1, 1, this is 1, 1, and this is 1, 0. K map. So I am writing here 0, 1, 2, 3, and what is this? 4, 5, 6, 7, and we know that this is A bar, this is A, this is B bar, C bar, this is B bar C, this is BC, this is BC bar. See here. So 0, 1, 6, 7 is given, 0, 1, 6, 7, 0, 1, 6, 7 given, and don't care is also given 3, 5. I am writing don't care here like this, don't care. Then we are grouping, minimizing. Sometimes we require to minimize don't care, otherwise we are not required. So I am grouping these two, I am grouping these two. I am not using don't care here. Don't care we are using, but if I use don't care like this, then 3 terms will come, but here only 2 terms. So if I group these two, see here, A bar, B bar, C bar, A bar, B bar, C bar, plus A bar, B bar, C, A bar, B bar, C, C, I am coming A bar, B bar, so C plus C bar, C plus C bar is what? 1, so what is this one? A bar, B bar, see here, A bar, B bar. Similarly, if I grouping here also this one, what is this here? A, B, C, ABC plus ABC bar. ABC bar. ABC plus ABC bar. Here also I am taking common AB. AB into C plus C bar. C plus C bar is 1. What is this answer? AB. So, what is the correct answer? A bar B bar plus AB. Plus AB. AB. Here. So, A plus A bar B bar, this is wrong. This is also wrong. This is also wrong. The correct answer is what? Option 1. A bar B bar plus AB is the correct answer.